I'd like to thank everyone for coming. My name is Lisa Plevin, and I wanted to share a few words with you about a project near and dear to the hearts of many in this room, the Parsippany Bat Protection Project. The Parsippany Bat Protection Project is an initiative of the Parsippany Green Team. Its goals are to educate people about the importance of bats in the ecosystem, to provide local bats with suitable habitat, and to humanely reduce conflict between bats and people. We also work to create and protect habitats for bats by identifying local areas most suitable for bat houses and working with local scouting groups to build them. We have installed 4 bat houses in local parks, actually maybe greater than 4. And we're always on the lookout, by the way, for new and suitable sites for bat houses. So if you have any thoughts, come talk to us. Another important goal of the Parsippany Bat Protection Project is the protection and creation of natural habitat for bats, such as shagbark hickory trees. Bats will roost under their loose bark, and we've planted numerous shagbark hickory trees in local parks as well. Also, last year, we organized the first ever Batapalooza, as we called it, in New Jersey, and combined it with the first Parsippany Green Fair. We focused on educating children by creating bat-related lesson ideas, activities, and resources for teachers and school librarians. So if you're a teacher or a librarian, we've got great lesson plans that we'd love to share with you. And believe me, kids love bats. And last but not least, we know that educating people is critically important to bat protection efforts. Therefore, we organize several bat walks per year, which are both educational and a lot of fun. So we have a website and a table here. Anita, you want to? There she is. We have a QR code that'll take you to our website if you want to learn more information about us. We have a sign-up sheet if you want to just give us your name and email, and we'll keep you posted on bat-related projects and activities. And I'm very excited to introduce the Rutgers Wildlife Conservation and Management Program. They have terrific bat resources programs focusing on education and conservation. They have served as the Bat Protection Project's technical experts for pretty much everything we do and have led all of our bat walks to date. We're very fortunate to have several students from that program staffing the table right there. And it is my pleasure to introduce our next presentation, being given by Evan Drake, a PhD candidate for the Rutgers program. Evan has awed audiences on our bat walks with his combination of knowledge and humor. So you're going to love his presentation on bats, New Jersey after dark.
You know, it's weird. Parsippany has definitely been the most welcoming to our BATS program ever. I'm a bit more used to fighting the uphill fight. They're not the most charismatic at first glance. They're a little hard to find, a little hard to see. So I have a lot of fun talking to this group. So we've got some experiences, and you touched upon a lot of what I like to talk about. Bat habitat is my thing. That is the topic of my dissertation. It's what I read about every day. Bat habitat, and more, how that bat habitat overlaps with human habitat. Because you see, the thing is, it's not all good, but it is also not all bad. We have some mixed reactions. So this road, we have this notion that any human development is going to be some kind of detriment. But look at this. Isn't that kind of nice? You see, if you were a bat, a small flying animal darting in and out of the woods, you might get tired of weaving through branches and trees after a while. Sometimes a nice little wooded corridor like this might be welcome. Bats, in fact, follow trails. They follow rivers. They follow roads. It's an easy, straight shot for them to fly down. Particularly this type of road that has the canopy kind of closing over top of it, it still gives them some cover. It's nice and comfortable, but it's an easy flyway. Compare that to something like this. a little bit more intimidating. Most bats will actively avoid certain streetlights. It's sort of a cost-benefit thing. Sure, sometimes the streetlights, they attract bugs, and the bugs attract the bats, but more often than not, a busy, wide, well-lit road like this with not a lot of forest on either side, most bats will just simply not cross it. They will come close and then turn around. Speaking of mixed effects, I know we just got done talking about agriculture. However, it's not all good and it's not all bad. That is the running theme. Sure, the agricultural industry replaces a lot of forest, and forest is important for bats. But agriculture also attracts insects. Insects attract bats, and many farms and farmers are very pro-bat. They will actively set up bat boxes on or near their property because we've had a great wealth of literature and studies examining the effects of bats on farms and our food production. And I get a lot of mileage out of graphs like this. It's so easy to justify my research. It is a luxury. When people ask me why I study bats, I have numbers I can pull out of my pocket on a moment's notice. I can tell you with confidence that bats save at least $22.9 billion with a B annually for the agricultural industry. That number comes not only from saving our food from insect damage, meaning we can sell more product because we are growing and saving more, but it also comes from the savings that we no longer have to apply as many insecticides. We've got natural biological control. Working in tandem with birds during the day, we've got bats taking the night shift. They are the only predator of flying nocturnal insects, except maybe other flying nocturnal insects. Dragonflies do some heavy lifting. That's agriculture, but urbanization is another big one. And that is sort of a homogenizing effect, meaning that it's not necessarily bad for all bats, but the bats that it is good for, it's just making them extremely common. It's making the common more common and the rare exceedingly scarce. So some bats are certainly being hit harder than others. Some bats, like the big brown bat, we've got some preserved specimens over there, hint, hint. The big brown bat is actually doing quite well. It adjusts well to human environments, it sleeps in our buildings, it hangs out, it's not that bothered. But others, more endangered bat species, they are forest specialists. So it is a mixed result where the rich get rich and the scarce get scarcer. And that's a shame, because that diversity is a precious thing. Bats fulfill a lot of roles, not just for our pockets, but for our ecosystems. In New Jersey, we don't really have many bat pollinators, and we don't really have any fruit bats. No. In New Jersey, all 9 of our species eat insects. All 9. We've got, at least on paper, there are 9 species. But let's talk about the eastern half of the United States. Not just New Jersey, but in the whole eastern half, we've got quite a few species. And I'm guilty. When I was little and I was drawing a bat, what color do you color it? Black. Yeah. But very few bats are actually black. Take a look up there. We've got quite a range, and they all have these convenient little mugshots if you look up their names. We've got a nice little book over there if you want to check them out. Some of them are in fact quite cute. Personal favorite is the orange one. That is the eastern red bat. It's like a little hamster. Others are grotesque little monsters, but they are beautifully adapted. I guess I could say that. Their form certainly serves a function. Anyway, the point of showing you all this is the unfortunate truth that many are in danger. Very few of these are common and doing well no need to step in and help. A lot of them are threatened. The threats vary. One of which is ironically and, painfully wind energy. It's you're damned if you do and you're damned if you don't. There's a whole lot of upsides to renewable energy like wind, but one of the unfortunate side effects is that it messes with migratory birds and bats. It is not that the wind blades are chopping them out of the air. It's not like that. It's that the spinning of the wind blades creates a low pressure area. And things in nature like to flow from high to low. If I'm a little bat or a bird flying by, guess what? My lungs are a high pressure area. When I fly by a low pressure area and I am a small animal, sometimes my little lungs pop. Yeah. We've made some progress on this. A lot of that can be mitigated by slowing the speed at which the wind turbines turn, and we're seeing a huge reduction in mortality where we have done that. But there's still death. For the non-migratory species, the ones that sleep in the caves, oh, if we don't get you going, we'll get you coming. The ones that sleep in the caves, they are getting decimated by a fungus called Pseudogymnoascus destructans, more commonly known as white nose syndrome. It's like a very unpleasant alarm clock. It just keeps disturbing you and waking you up while you're trying to sleep and save energy, and you waste all your energy waking up and flying around because you're irritated and you're trying to So you just run out of fat reserves and you die. When this first hit in around 2006, people were going into caves and stepping over piles of mummified bats. It dehydrates them, it starves them, it wakes them up, and they can't find enough food to replace the fat that they've lost because it's winter. Where are you going to find the bugs? They're gone. So it's rough times. And in addition to the wind turbines and the fungus, on top of that, there is the ever-present threat of habitat loss. This is from a review of the top threats to bats globally. I can conservatively say that almost all of them are related to human habitat change. If I wanted to be a little bit more inclusive, I could also tack climate change on there. That is human-related habitat change, but I was like, all right, let's do an underestimate. Speaking of bat habitat and how to, recognize it when you see it, protect it when you have it, I'd like to tell you a little bit about how bats use our world. The first thing I want to bring up is that forests, in any capacity, are great resources for bats. Not all forest is created equal, and there's certain parts that they like more than others, of course, But forests serve an important role for all New Jersey bats at some point in their life. We have bats that don't sleep in trees. We have bats that sleep in caves during the summer. They never sleep in the trees and roost around there. But they do go there to forage. We've got a lot of bugs zipping around in there. It's a great place to hunt. It's safe. It's sheltered from predators. And don't get me wrong, bats do have predators. The full moon is often met with a reduction in bat activity because it makes them a little bit more visible. An owl could pick you off. Things you don't think about very often. But yeah, they do need cover from predators. And, as mentioned before with the shagbark hickory, for sleeping resources, roosting, that is a picture of a shagbark hickory. It earned its name. It's got shaggy bark. Normally, bats like to sleep in the not peeled off all the way bark of a dying tree. That, as you can imagine, is hard to come by unless you've got a nice source of dead trees. Shagbark hickory is one of the few trees that they can use while it's still alive. Dead trees tend to fall over and be unusable after 2 or 3 years? So unless you've got a steady source of death, its habitat is hard to come by. So indeed, shagbark hickory is a good way to go. And commuting. Not all bats stay in the forest where they're at. They're often using it as a nice, safe passageway to their actual foraging grounds. Maybe they're going to a meadow or something, but to get there, they don't want to just fly through open air. Dangerous. Stick to the safety of the forest. But forests are not the only places that attract bugs and therefore bats. Does anybody know what I'm getting at here? I'm getting at water. One is, as I mentioned with that road example, bats like to follow corridors. Streams are the natural equivalent. Like back before the days of humans and us cutting trails and cutting roads, bats like to follow streams. When we set up our mist nets in the forest to catch the bats, we often do it either over a trail or over a stream because bats are zipping up and down following it. They're following it not only for ease of commute, but also because water attracts bugs. You see them swarming around in a little like cloud or tornado above the water surface, and you've got bats zipping back and forth picking them off. No brainer. But it's not only that. Bats are animals. Bats got to drink. So forests, water, maintaining the quality of those, high priorities. Keeping dangerous chemicals out of our water, reducing the amount of pesticides around there. If you've got a lot of pesticides in your water, you're not going to have a lot of bugs. If you're not going to have a lot of bugs, you're not going to have a lot of bats. And then, weirdly enough, a pretty scarce habitat around here. I mean, we've got forest. It's not the best. It's kind of scrubby. It's got thorns and whatever. But what we like is to take open spaces and think, oh, how can I use that for something else? But really, that's resulted in kind of a scarcity of nice, open, natural fields. If we've got an open field of grass, it's normally for the purposes of soccer or something. But really, open spaces for bigger bodied bats, they're crucial. Not every bat. We've got that board over there, that's kind of not representative of what we have in New Jersey. But still, in New Jersey, we've got size ranges. Bigger bodied bats aren't great at zipping around in the forest. They're built more for flight speed rather than maneuverability. So, some prefer their insect prey in a straight chase out in the open field rather than zipping around and using their maneuverable flight to zigzag through the trees, pick off a bug. Some bigger bodied bats aren't good at the zigzag. They zoom fast. These are things like hoary bats, which is the biggest species of bat we have in New Jersey. They're known for being open field specialists, among a few others. And the field has to end somewhere. You see back there? Forest edge is a great interface between the forest and the edge, you know? They like the safety of the forest and the cover it provides, but sometimes they'll dart out, grab a bug, dart back in. They like to go back and forth, and you get a lot of action at the edge. I do a lot of my work when I set up. I'm going to talk about how we study bats right after this. But a lot of my work happens at the forest edge or at a water source because the edges of the forest and the bodies of water, that is where you get highest bat action, period. And how we study bats, it varies. We've got a lot going on in that lab over there. One of my colleagues and friends, who's not here today, is Erin. She is the bat poop woman. She mist nets in the forest at night. She catches the bats, she handles them, and then they poop for her because they're scared, as one does, and she collects them. And it's a process. You set up the net at night. You go out there with a team. I don't do much of it myself. It's probably miserable. And then what you do is you catch the bat, and we want to know more about where this bat is going, what it's doing. So you attach a little tiny transmitter to its back. And yeah, they have to be really small. And then you can go out there with in the bottom middle, she's out there with a radio receiver listening for the little transmitter that we put on the bat. And what you can do is you can follow it back to the tree that it's sleeping in and go, oh yeah, I guess that's what it likes. Let's wait until it switches roost and see if it picks the same thing. Oh yeah, I guess that's what it likes. When we're saving trees, maybe this is what we should go for. Things like that. That's how we know where they sleep. And then she takes that poop and analyzes the DNA to see what they're eating. And exciting news. I'm sure they don't prefer it. I'm sure they taste terrible. But they have detected spotted lanternfly in bat poop. Probably not a lot of it, but it's there. So, moving on, I'd like to talk briefly about Daniel's research, which he will know more about than I do. But he does what is called eDNA monitoring. He will go to bridges around the state and sort of swab test to see if I can detect bat DNA without actually having to see the bats, because bats are hard to see. He goes out there with paint rollers and he gets samples off the bridges and he tries to see, hey, can we see any bats around here? Sometimes it involves a boat. I hate boats. I'm glad I'm not a part of that team. But look, you see in that little crack? No, of course you don't. Let me blow it up a little bit. There's like, how many bats are in there?
Oh my God.
There's like 30 little bat faces stuffed in that bridge. You wouldn't know unless you were either looking for it or testing the environmental DNA. It's a great method of detecting bats without actually having to detect the bats. Knowing whether a bridge is in use or not could be instrumental. My thing is more like acoustic monitoring. I set up my microphones. I did a thing on golf courses, which was a lot of fun. But I set up my microphones either near the forest edge or the edge of a body of water, and I record them as they fly around echolocating. And bats are loud. Bats are essentially screaming at all times. And this is what it looks like. This is what my microphone picks up. And yeah, that doesn't really look like much. And if you compare it to this, I guess you might be able to say that one is a little bit more high-pitched than the other, but at first glance it doesn't look like there's much of a difference until you zoom in on one of those lines. And then you see, oh wow, they look quite different. And in fact, they are. I can look at a readout from one of my microphones and tell you what species of bat is doing the screaming. So, leaving my microphones out for a couple days, collecting the data, and oh, there's a lot of data, you scroll through, I can tell you what species of bats were there that night, just by listening to them. That's where my research takes me, and I get to answer a lot of questions about habitat use that way. And now, just for your viewing I don't want to call it pleasure. It's a little bit of an annoying noise, but I'm going to play it for you. So you can't actually hear it in real life. This is a recording that has been slowed down by about 10 times. This is 10 times slower than it should normally be. And what you'll see there is you've got a little bit of a squiggly fuzziness in there. There's a blob in the middle, and I'll let you listen to it first. Coming up. There, that little drum roll. What happened there was that the bat started echolocating very, very quickly. That happens when they detect a bug. We just detected a hunting behavior in that bat, and that's something else I look for on my microphones. When you're flying around doing your screaming thing, you get a rough image of what is going on around you, but when I detect prey, small, fast-moving prey that is trying to get away from me, I need more up-to-the-moment information. I need to know. I need to echolocate more often. I need more information. So when they're closing in on a bug, they do that thing. We call it a buzz. And that was pretty much my lockdown project during the early days of COVID. It drove me crazy. I hear this in my sleep. It's so annoying. It's a special brand of annoying. But that's it. And if you have any questions for me, I would love to answer them either here or at our table. Yeah, we got one.
The white-nosed bats how do you prevent that fungus?
Prevention. So the fungus is actually pretty sensitive to UV light. That's why it only grows in the caves. So we've got a guy who's been taking one of those sanitization machines that they use in hospital rooms and taking the UV light into caves and blasting the walls with UV to try to kill all the fungus. and seeing how that goes. And in the lab, it seems to work. The UV does kill it. Practical use in the caves is still under research. The fungus was introduced from Europe. Yes, the bats in Europe have had this fungus around them for a long evolutionary history, so they have a higher resistance. The fungus came here to America from spelunkers or something, and our population does not have defenses against it. It's like, biological warfare. So they come in, they're not ready for it, and it wipes them out.
You mentioned you did some work with golf courses.
Yeah.
What was the data result for that kind of study?
So I was testing to see whether golf courses in maybe more urban landscapes versus golf courses in more natural forested landscapes get different levels of bat activity. And what we found was, pretty much what we thought. It seems like in a concrete jungle, the golf course is the one island of green. So the bats kind of congregate there a little bit, and it's an important habitat patch for them. So when they have nowhere else to go, they go to the one thing that most closely resembles natural habitat that they have. The golf courses actually do kind of take pride. It's like a feather in their hat if they are considered eco-friendly. Good. So talking to the people and seeing their pesticide regime and all that, golf courses have a bit of a bad reputation for their land use change and how it sort of treats the landscape, but it's better than a mini mall. And I'm finding that not a lot of pesticides or fungicides, it's not like it's a regular thing that they put out every week. It's sort of like as needed. It's like symptomatic. If I'm a groundskeeper and I find like a patch of fungus or something, I might sprinkle a little bit on that, but it's not like they cover the whole course in it every week. I found that the average golf course was a lot more environmentally friendly and really excited about bats than I expected them to be. As long as their water is clean, I would expect that they would be great places for wildlife. I saw turtles there, I found a lot of frogs, there were a lot of turkeys. It was fun. And I wasn't expecting it to be. And I got to ride a golf cart. Yeah. I think I have time for one more.
Are they starting to regenerate now? Are they starting to increase? I know their population has been diminishing. So how is that going?
You see, bats reproduce quite slowly. They will only have like one baby a year, as opposed to a mouse who has like 6 babies at a time, and they can do that multiple times a year. So after the big decline, it's taken a long time to pull up out of that nosedive, but we are starting to see it. When we do the counts, when they're hibernating, you go into the caves, and while they're all just sort of huddled in one place, you can get a good count of them. And that's where we're noticing the numbers are starting to recover a little bit. They're still much lower than they were before the big hit, but there's hope. Thank you.